Improvements in technology have decreased the need for the visually impaired to learn Braille, thanks to the introduction of ebooks alongside text-to-speech technology. However, only a handful of books have an ebook counterpart, and only a handful of those have TTS support. A study from Skolno, a membership organization for all academic and national libraries in the United Kingdom and Ireland, cites that only around 10% of current academic titles are available as ebooks. This is only made worse by the fact that many ebook publishers do not include a good TTS function, if not at all. In fact, some ebook publishers, in an attempt to fight against privacy, have unintentionally made it impossible for TTS browser extensions to read the text on the screen, making certain books impossible for the visually impaired to access. The theme of HackCamp revolves around inclusivity, diversity, and accessibility. We saw that the lack of accessibility that individuals with visual impairments faced in trying to attain what we as students deem are essential failed to include the diverse needs of people. Thus, we created Eyelexa, a combination of the English word eye and lex, which in Greek means speaking or speech. Eyelexa is a solution we developed in order to tackle the accessibility issues that many visually impaired people may have come across.
How does Eyelexa work? Eyelexa has been specifically developed to tackle edge cases that often do not have better alternatives other than finding someone else to read the book aloud. Suppose a visually impaired reader only has access to a physical copy of a book, possibly because the publisher did not release an ebook version, or because their local library carries the physical copy but not the ebook version due to outrageous subscription prices. Now with Eyelexa, anyone can read physical books easily, with only their computer and a webcam or a phone. After opening your website, all the user has to do is place their reading material in the correct position and use their keyboard. Keeping accessibility in mind, we made all controls on the website accessible with a keyboard without the need for visual input, although still displaying optional visuals for those who may be figuring out how the program works with someone who is not visually impaired.
You might ask, couldn't a blind person just take a picture of a page and just use a software like Google Lens or Apple's new Live Text? Well, it would certainly work, but a function like that comes with many caveats. The first problem is that if using a phone, it's difficult to position the book to take a picture. Lifting your phone up to read every single page of a book is cumbersome, and especially without vision, it may be very difficult to align the camera such that the full page is scanned. Even if a phone stand is used, each subsequent tap on the phone may change its position, which may cause discomfort while reading. Because all user inputs to Eyelexa are done through a keyboard, there's no concern of accidentally adjusting the camera. Furthermore, a keyboard input, as opposed to touchscreen input, allows easier use as a keyboard does not require vision to use, since unlike a touchscreen, it has physical buttons that can be felt using fingers. Another benefit to Eyelexa is that it can play in addition to moving forward and backward, a feature that many TTS softwares lack.
So, how did we build it? What technologies did we use? When the user takes a picture on the browser, which was built with HTML, CSS, and React.js, it sends the image to the backend server using an HTTP request.
French English, the quick way to learn more than 6,000 French words and phrases. Features a complete range of illustrated objects and scenes from everyday life to evo learning for any situation.
That HTTP request is received by our backend server hosted on Heroku, which uses Google Cloud Vision API to determine the text on the screen and returns it back to the front end to be dictated back to the user. We're quite proud of the accuracy and performance that our program has in correctly identifying the words in addition to how easy it is to set up. Without using an external webcam, it took us less than 10 seconds to start reading. And with an external webcam, although it took a bit longer, it could still be done very quickly. Although this program began as a way to make physical books more accessible for visually impaired users, we soon realized that we could extend this to various other domains, such as helping people read not necessarily books, but possibly labels or instructions on food products or medicine, or use this to easily bulk digitize a series of handwritten notes or books without the need for expensive, specialized hardware. In the future, we also hope to make this even more accessible by making a way to easily connect your smartphone to your computer, so you could place your phone on a stand to use a webcam.